Hey there, 2.8.1, we are going to be working with proofs part 2. The warm-up is actually a continuation of 2.7 where you had a flowchart proof and a 2-column proof, and you're going to kind of take all of that and compile it into a paragraph proof. So if you want to pause the video without reading what I wrote here, go ahead and do that and give it your best shot. Meet me back and then look at what we've written. Okay, so I'm assuming you're meeting me back. It is given that the measure of angle 1 is equal to the measure of angle 3. Using the addition property of equality, we know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Using the angle addition postulate, we know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle RTG, and that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle WTM. Next, we can apply the substitution property of equality to determine that the measure of angle RTG is equal to the measure of angle WTM. By definition of congruence, we reach our conclusion that angle of RTG is congruent to angle WTM. All right. So we're going to look at a different proof over here. Proofs, remember, they take a lot of practice, but one of the best things that I like about this is it talks about brainstorming. So before you write a proof, look at what you're given, your given statements, which are here, your drawing, and then what it is that you're trying to prove. So before Gabby and Samuel wrote their paragraph proof, they brainstormed. Here are their notes. Okay, and Gabrielle, and I keep messing that up, so that's why I'm calling him Gabby, or calling her Gabby. Gabby marked up her triangle with congruent marks. It's given that HL is congruent to WR, so that's where this first congruent mark is. And LT is congruent to WT. So that's what we have here. Gabby further states that she knows that HT is equal to HL plus LT. She has a little note there that says adding 2 segments to get the total. What is that called? Hopefully you remember that it's the segment addition postulate that we had in the last unit. Also, this is big because some students were forgetting this in the last couple of days. If you're using the equal sign, then it has to be changed to congruence. Okay, so if we're using the equal sign here, we're going to have to change it to congruence. So we're talking about the definition of congruence in there. Samuel has the same triangle drawn. He has the same given statements. We have to prove that LHT is congruent to TR, and he says don't worry that this is backwards, it's the same as RT. So HT is congruent to TR, and he's realizing that even though that it says TR, that RT means the same thing. Basically, if you add 2 segments of each side, you get the entire side. So he's also talking about what Gabby's talking about over here. So let's let this guide us through our proof. And by the way, this is a long section, so we actually took 2 days on this. So hopefully this video won't be too terribly long. Why did Samuel write, don't worry, it's the same thing as RT when he had TR written down? So we know that when it comes to naming a segment, that segment TR and segment RT represent the same segment. So order of those segments don't matter, or order of those points do not matter. Gabby made some markings on the triangle she drew. What are her markings meant to show? Well, we talked about that as we went through it. They are meant to show congruence. Gabby wrote HT is equal to HL plus LT, but she could not remember what that was called. Samuel wrote, basically, if you add the 2 segments of each side, you get the entire side. What postulate justifies Gabby's statements? That would be the segment addition postulate. I'm running out of room, so I'm just going to put it down here, the segment addition postulate. Gabby only wrote HT equals HL plus LT. But Samuel mentioned each side. Write the equation for the other side. So we would have, let's see, RT is equal to RW plus WT. Gabby wrote, if using the equal sign, then it has to be changed to congruence. What definition justifies changing equality to congruence? That would be the definition of congruence. There we go. I'm having a hard time writing today. Okay. Apply the brainstorming of Gabby and Samuel to finish the paragraph proof. Use the first sentence has been written for you. Okay, so we took a long time and let everybody kind of write it out the best they could. Remember on the EOC, you're more than likely not going to be writing a paragraph from start to finish. You will have like some drop downs or some click and drags to be able to do that. But we're going to give it a shot. So we always start with our given. It's given that HL is congruent to WR and that LT is congruent to WT. We know that we're going to use the segment addition postulate in some form or fashion. And the segment addition postulate is equality. So we've got to move from congruence that we have up here to equality, and then we'll move back from equality to congruence. So I know I'm going to be using the definition of congruence in there as well. Then we might be using some other things such as substitution, transitive, all those other bags of tricks that we've learned over the past weeks. All right, so let's go ahead and get started. It's given that segment HL is congruent to WR and LT is congruent to segment WT. By definition of congruence, and I'm going to abbreviate a lot here. So by definition of congruence, we know that HL is equal to WR and LT is equal to WT. So we just wrote the given statements again, but changed the congruent sign to an equal sign. So now that I have them equal to each other, then I can use that segment addition postulate. So I know that HL plus LT will equal HT. Okay, so I'm just showing this part right here. Okay, and try that again. And I know that the other side, I'm going to have RW plus WT is equal to RT. That part right there. You know what? I'm going to change that where it says equal to RT. I'm going to flip it. And the reason why I'm going to flip it is because our proof statement has TR. So I'm going to put TR just so it'll be a little less confusing later on. Okay, and I did not put my reason there. So I know all of that by the segment addition postulate. Okay. So I need to make a connection between the two. So I'm going to make the connection with HL and WR. So since segment HL is equal to WR and let's see, LT is equal to WT, then by substitution, I can write WR plus WT is equal to HT. So do you see what I did there? I took HL is equal to WR, so I replaced HL with WR and LT with WT, and that gives me HT, or is equal to HT. Okay, so now I have this right here. And if you look at it, these are the same, even though my RW and WR backwards, those are the same thing. So I have this side right here and this side right here. Those are the same thing. Okay, so basically I have X equals Y and Y equals Z. So therefore X equals Z. So hopefully you're thinking of the transitive property. Sorry for the noise. Okay, so by the transitive property, HT is equal to TR. We're almost there. I've proven that they're equal to each other. So I know that there's only one last thing I can do. If the sides are equal to each other, their segments are congruent to each other. So in conclusion, HT is congruent to RT by the definition of congruence. That was a little bit tough. All right, the next part of it is just kind of thinking to yourself, what was the most difficult part of writing the paragraph proof? Probably for me, it's starting from scratch and going all the way through. There's nothing really to guide you there. But if you go to number 8, how did Gabby and Samuel's brainstorming, how was that helpful? Well, it kind of made you think about what postulates and theorems could apply to that. We have in the classroom, we have a list of all those postulates and definitions that we've been using, and I rewrote it over here. So if you want to put that somewhere, that would probably be great. We also flip-flopped our proofs with other people in the classroom, let them read through it, but I just gave you the proof, so there you go. Okay, that ended up with Wednesday's lesson. We started today over here and finished this up. So we're looking at a flowchart proof, and there it is, and we're going to do a 2-column proof with it as well. So we're going to brainstorm first. Now again, this list that I have here is pretty much most of the proofs and theorems and definitions that we've gone through. They are not in alphabetical order. As I was thinking of them, I was putting them down. We have this list on the back wall, and I suggested to everybody that they should, put it on a piece of notebook paper or something and keep it nearby. All right, so here is our proof, or here is our given statements. We have our given, we have what we're trying to prove, and we have our diagram. So we have 2 segments. We have AX and DY. The given statement is K is the midpoint of AX, L is the midpoint of DY, segment DY, and we know that the 2 segments are congruent to each other. So we've got 3 pieces of information there. That's the given statements. Now, what does it mean if we have a midpoint? Well, a midpoint is in the middle of the segment, which means that it's cutting that segment into 2 congruent or equal halves. So I know that AK is congruent to KX. I know that by what is it that tells me that? That would be the definition of a midpoint. That's what a midpoint does. The same thing is going to happen in the next segment. And because the two segments are congruent to each other, then I'm only going to use one congruency mark right here. So if I think about it, this segment right here is also congruent to this one here, which is also congruent to this one here, which is also congruent to this one here. So we'll go back to what we're trying to do. So brainstorm with your partner how to write the proof. And again, what we're trying to prove, or maybe not again, but what we're trying to prove is that segment AK is congruent to this segment over here. We know that's what should happen. We have the midpoint. We just have to somehow correlate those two together. And I would think if we're going through here, we might be using the segment addition postulate because we have a segment up there that's broken into two parts. We will probably use addition, okay, somehow in there. If we're using the segment addition postulate, there's possibility that there's addition in there as well. Do I have, oh yeah, definition of congruence. Absolutely. If we're using segment addition postulate, we have to change our congruent segments into an equation. So we have to change from congruence to equality. We already said definition of a midpoint. There might be some substitution going on. There might be some transitive property going on. And maybe some other stuff going on. Okay, so that's just kind of what we're thinking, and we're going to use all of that over here. Now, what I love about this is that it's guiding us through. Okay, and what I need to see those two segments again. So I have to just kind of draw them out, and we'll pretend that they're perfectly congruent. Okay, so I have segment AX, and K is the midpoint. Over here, DY, and L is the midpoint. So these are easy. These are your givens. I'm going to guide you through this, but what we had the class do is they worked on it on their own, and then they switched up with other people and tried to make sure that they were on the right track. Then they called me over to see if they were doing well. So what I'd really like for you to do is to pause the video and see how far you can go, and then come back and check and see how you did. So we've got those given statements, and this is going to bring me down to another box. Well, what does K being the midpoint of segment AX mean? Well, we know that if K is the midpoint, then segment AK is congruent to segment KX. And that reason is the definition of a midpoint. Okay, and we've got the same thing going on with L. We have DL is congruent to LY. Same reason, definition of a midpoint. Okay. And then what we have here with the third given statement, segment AX is congruent to DY, and then we go to AX is equal to DY. We're going from congruence to equality. So what we're saying there is that is your definition of congruence. And then kind of over here and this over at the side, I have AK plus KX is equal to AX. All right, is equal to the whole thing. And then DL plus LY is equal to DY. Well, that is your segment addition postulate. Now, we can just take from definition of a midpoint down to here, all you're doing is you're going from congruence to equality. So that is definition of congruence again. And same thing here. We're going from congruence to equality, definition of congruence. Now we've got to take these two to see what's going on there. So I have this and I have this, okay, which is part of this right here. Okay, and it basically says AX, we have AX is equal to DY, that is referenced right here. AX is equal to DY, AX is equal to this, DY is equal to this. So I replaced AX, this AX right here, with this. I replaced this DY with this. When we're replacing, what property is that? Substitution. Now we're going to use these three boxes. There's 1, 2, and 3 to come up with this box over here. Okay, so I've got the equation again. Let me get rid of some of those circles because we need this again for the next one that we're doing. Okay, so I went from AK plus KX to AK plus AK. I went from DL plus LY to DL plus DL. Well, let's take a look at those other boxes. I have AK equals KX. Right, there's KX, which is now AK. So it looks like I substituted in AK for the second KX. Looks like I substituted in that AK for the other KX that was there. So if I look at the difference between those, I replace that. Also, on the other side, DL, this DL is equal to LY. So I replace this LY with DL. So again, I've replaced. That is going to be another substitution. All right, now comes the easy part. We're just going to go from there. I have AK plus AK equals DL plus DL. How does that become this? Some people said, oh, you multiply. No, you're not multiplying. AK plus AK is just 2AK. DL plus DL is 2DL. All you did was add. That's the addition property. I'm having a hard time spelling tonight, okay? I sure am. Woo, it's late. Let's try that again. There we go, much better. Okay, now how do you go from 2AK equals 2DL to just AK equals DL? Well, you divided each side by 2. So we would just say division. That's what we did there. And then how do you go from AK equals DL to segment AK is congruent to segment DL? Well, that is the definition of congruence. If anything, I hope that you were able to really understand the definition of congruence. We're going to take that proof, and I really want you to pause and try to fill it into the best of your ability. Use the flow chart to help you complete the 2-column proof. Pause and then come back. All right, now that you're back, we've got 2 parts of the 3 givens. We've got K as the midpoint and L as the midpoint. Again, what do those midpoints do? They break them up into 2 congruent pieces. And that is our definition of a midpoint. we go from congruence to equality. So that is our definition of congruence. So just to make sure, if segments are congruent, they have equal measure. If they have equal measure, they are congruent. That's what the definition of congruence tells us. Number 4, we have our third piece of given information, that the two segments are congruent to each other. And we are trying to figure out what would go in number 5, and it looks like we're going from congruence to equality again, especially when it's given us that definition of congruence. So I'm just going to rewrite AX is equal to DY. Okay, and then we have this part up here, okay, our segment addition postulate. Okay, then they're showing us the substitution for the next one, which is this over here. Then we have our AK plus AK equals DL plus DL. That would be substitution again. Okay, then we have our 2A equals 2DL. That would be addition. Then we divide each side by 2. And then we convert back to congruent. So definition of congruence. There you go. So let's see, do we have anything else going on? No, just your wrap up. So that is it. That was a very long video. Hope you were able to stay with me. We will have our test review, and I will post that in Schoology. Have a great day.